Okay, what we're going to do is change gears a little bit and start looking at what we refer to as solutions. What we're going to do with this information then is apply it to different topics, such as acids and bases. So when you think of solutions, one of the easiest way to think about a solution is think of something like Kool-Aid or lemonade, or iced tea for that matter. You've got to take something, put it in water, and it dissolves. So for example, the Kool-Aid, you're going to take the powder, you're going to dissolve the powder in the water, and then you're going to have a solution of Kool-Aid. So initially you've got the powder, and then you've got the liquid, but then when you put those two things together, you've got a solution of Kool-Aid. So what we're going to do is look at the thing that gets dissolved, which we call the solute. So for our Kool-Aid example, that would be the powder. Then we're going to look at the solvent, which is the thing that does the dissolving. Usually for us it'll be water. So in our Kool-Aid example, it's exactly that, the water. And then when you put those two things together, the end result is what we refer to as the solution. So as we're doing these problems, you always want to think, what's the solute and what's the solvent? When you put them together, they form the solution. So why do we study solutions in the first place? Well, if you noticed, we started talking about gases, and we studied the gas laws to understand how molecules move in the gas phase, and we also studied solids. Now, we haven't studied solids in detail in terms of their structure, but what we did do is we talked about grams and moles, and then we applied that to law of conservation of mass. Well, solutions, now we start taking a look at liquids and the different properties that liquids have based on whatever the solute is, whatever it's dissolved in, and then that makes up the solution. So we're simply advancing our study of matter by looking at liquids as opposed to gases and solids. Okay, as we've talked about already, we've talked about the solute, and that's the substance being dissolved. We've talked about the solvent, that's the thing doing the dissolving. Now here it says liquid water, and for us it'll always be liquid water, but you do need to know when you move on in chemistry, there are plenty of other solvents that are not liquid water. The stuff that we study will all be dissolved in water, so the solvent will be water, but just realize it's not always water. And here's a new term that we want to talk about, an electrolyte. An electrolyte is simply something that conducts electricity in solution. Now, as we continue our discussion, we'll talk more and more about electrolytes, but what you want to think about with electrolytes is if you have a system, and when I say a system, I usually mean a beaker with water as the solvent. If you put a substance or a solute into that solution and it breaks apart into individual ions, both positive and negative, what will happen is you'll produce an electrolyte. An electrolyte is going to produce, or I should say is going to conduct, an electrical current through the solution. So if we were to have an electrode here and an electrode here connected by some power supply, that current would travel from positive to negative throughout the current. Non-electrolytes do not conduct electricity through the solution. And again, as we talk about this in terms of different types of solutions like acids and bases, that term will become very important. As we talk about solutions, what we need are units to help us with the math. The unit that we're going to use for most solutions is molarity, and it has the symbol capital M. Molarity is moles of solute over liters of solution. Now this is important because we're going to talk about another unit later on where we use kilograms of solvent, so you want to make sure that you understand it's liters of solution. So after you put the solute in the solvent, the total volume there would be your liters of solution. So let's say, for example, we are going to make a 3 molar, and that's the way you pronounce it, molar HCl solution, you could do that a number of ways. Typically what you would do is take 3 moles of HCl over 1 liter of solution, or you could have 6 moles of HCl over 2 liters of solution. To be honest, I'm not sure why I have it like this, because that's a little confusing. You're talking about moles of the solute, and in this case it's hydrogen chloride, over liters of solution. So when you do the math there, 3 divided by 1, we would say we have a 3 molar solution of HCl. Or you could say its molarity is 3 molar. Obviously 6 divided by 2 is 3 also, and that's why those numbers are there. But sometimes it's easier to think about it with a 1 in the denominator. So as you've seen with a lot of the problems that we do, we use the units to help solve problems. So if we say what's the concentration, when we say what's the concentration, what we're saying is what's the molarity of the solution. So we need the moles of the solute and we need the liters of the solution. So we're talking about HCl here, and we have 15.5 grams of HCl, and we're putting it in 150 milliliters, 150 milliliter flask, assuming that's 150 milliliters of solvent. Okay, so we need moles of solute and we have grams of solute. So the first thing we want to do is convert grams to moles. So the molar mass of HCl is 36.5 grams of HCl per mole of HCl. Let's do the math here. And we get 0.424 moles of HCl. Now the one thing you want to realize here is that when we're talking about moles of a compound, usually that is not involved in the volume. So if we're talking about 150 milliliters of solvent here, we can say that that's 0.15 liters of solution. In other words, the amount of the solid that we're adding, we're assuming, is not affecting the volume of that solution. And we'll actually deal with that a little bit later, but for right now, we assume it doesn't affect the volume. So do the math. If you finish that off, you get 2.83 molar, or 2.83 moles per liter HCl solution. Okay, let's take a look at another problem. How many grams of magnesium chloride, so right away you should be thinking, all right, MgCl2, are required to make a 0.55 molar solution? So what we're saying is we have 0.55 moles of magnesium chloride per liter of solution, and we want to know how many grams we want to use to make that. Now we're going to make an assumption here, and this should actually be clarified in the problem, but we're going to make an assumption that we have 1 liter of solution. So if we started with 1 liter of solution and we're making a 0.55 molar solution, that way our liters of solution would cancel. We would have moles of magnesium chloride and then 1 mole magnesium chloride. Since we're converting to grams, add up the molar mass and you get 95 grams of magnesium chloride. Do the math now, and we get 52.25 grams of magnesium chloride. So what that means is we would take 52.25 grams of the solid magnesium chloride, we would put it in a 1 liter flask that was filled up to a liter, and we would have a 0.55 molar solution. Now if we were only making, say, 150 milliliters, then instead of starting with 1 liter, we would start with 0.15 liters, or whatever our volume happens to be. That's why you really do have to have the volume stated in the problem. Let's take a look at another problem, and this problem will illustrate that. We want to make 250 milliliters, so right away I'm just going to write that as liters, of a 0.75 molar NaCl solution. And it says, how would you make that? So what we need to know is how much of the solid in grams would we put in a 250 milliliter solvent to make that solution. So if we're starting with liters, 0.75 m means 0.75 moles NaCl per liter of solution. Our liters cancel and we have moles of NaCl, and now we want to convert to grams of NaCl, so 58.5, that's the molar mass. So our moles cancel, we'll be left with grams, and we get 10.9, let's just say 11 grams of NaCl. So we would take 11 grams of NaCl, we would put it in a beaker with 250 milliliters of solvent to give us that solution. Let's take a look at one more problem. We have 500 grams of potassium phosphate, so right away I'm going to write 500 grams potassium phosphate. It's dissolved in enough water to make 1.5 liters. What's the molarity? So remember, molarity is moles of solute over liters of solution. So that is our solute, so we need moles. So let's convert from grams to moles. So that's 212 grams K3PO4 per mole K3PO4. Finish off the math there. We get 2.36 grams of our solute, and again we're going to put that, whoops, I'm sorry, notice the mistake, not grams, moles. And here, that's a good example of why you want to include the units in the problem, because it's easy to make a mistake, and right away I thought that doesn't sound right, so I look back, my grams cancel, and the unit I should have is moles. So we have 2.36 moles. We're going to put that over our 1.5 liters, so when we do the math, the unit will be moles per liter, which is molarity. So finish off the math and we get 1.57 molar K3PO4. Okay, it's very important that you understand how to do these calculations and realize a few things. When we say concentration, for now we're talking about molarity. Now there are other units of concentration which we'll get to. Molarity has a symbol capital M, and its units are moles of solute over liters of solution. So if we have a 1.5 m NaCl solution, we would say it's a 1.5 molar NaCl solution. As usual, if you have questions, email them to Hannon in Chemistry. And again, as usual, make sure you do all the problems in your problem packet, because at this point it really is mostly math-based. So I will talk to you in our next podcast.